Hello, today we're going to talk about PhotoWX, our new weather service for photographers. We've spent the past few months thinking through what is it we'd love to see in a weather service that really takes into account the things that matter as outdoor or landscape photographers, architectural photographers, wedding event photography. How is the natural light going to interact with the weather? And by natural light I mean the sun, of course, but also the moon, the stars for night photography, astrophotography. We've started out focusing on weather maps. Weather maps give you great insight, especially if your location is something that you can control. And you really want to have a look and see how the weather is moving through an area so that you can decide where to go or not. As you might be able to tell from the light in the room today and the view through the window here of my shoulder, it's a bit of a murky day here in Boulder, Colorado. We've had fairly thick fog all morning, which is quite unusual for this area, and snow is meant to be coming in the next hour or so. So today's weather should give us some interesting things to look at in this area, but I'll look at some other areas too. The new service includes a number of different, what are called numerical weather models. So these are the large-scale supercomputer models that get run by different weather agencies around the world and are synthesized into maps by our service and then presented within our site for you to look at. There's a choice of models and they have different coverage, different resolution, different variables that they include. So I'll talk you through a little bit about what's available and how to choose and what to look out for in some of those models. So with that, let's jump into the site and I will give you a quick tour to get started. Okay, so let's start by looking at how do you find this new weather site. I'm starting out here at app.photoephemeris.com. That's our regular web app that I'm sure most of you will be familiar with. And you might notice up here there is a new link called WX with a little this is new asterisk next to it. And that is all you need to do to get to the new site. Note where I am here. I'm showing the map in Colorado. The pin is near Boulder, Colorado, where I am located. I'm going to click WX and let's just watch what happens there. Okay, so here we are. We're now in the new site and you'll see it's titled PhotoWX, wx.photoephemeris.com. You can navigate directly there if you want. If necessary, it'll ask you to sign into your account. And if I want to go back to the web app, first off, let me show you that. Just click back up here and that will take you straight back there. So it's as simple as that. So now that we're here, let's have a look at a little bit of a tour of this interface so you see what is going on. The main feature is the map. As you see, you'll see the familiar red pin and you can drag that around and drop it as you will, just as before. And it's showing the direction to the sun at the selected time of day, which is 10:30 on Saturday morning here in February. And to adjust the time of day, this is very similar to the altitude chart that you see from Photo Ephemeris web. Instead of a slider though, you just click and drag on the chart itself. So you can see as I'm dragging, moving with the mouse to the left, the time is advancing, the sun is advancing through the day. And you may have noticed that as I scrub back and forth there, you can see that the temperature forecast is changing. So let's talk a little bit about what you're looking at here. This is a colorized temperature map. The scale is indicated by the legend here at the bottom. You can click that to toggle the legend style so you can see the discrete values. I have it set to Celsius at the moment. Let me show you how you can change that to the units you want. Over here at the bottom right, so you can have temperature in Celsius or Fahrenheit. I'll click to Fahrenheit. And you can have distance, length, speeds as well in metric or imperial. So imperial will be miles per hour, metric will be meters, kilometers, that sort of thing. And so just reading this map, you're essentially looking at the color, correlating it to the scale back here. You can see that anything in blue down into the purples is pretty cold. What I can also do is drag this pin and I'll just drop it up on the mountains here. And what you might notice is that the point temperature data, this panel here, is showing you conditions at the red pin position for the selected time. And it shows you the general weather conditions, so snow up in the mountains, and a temperature of 6 Fahrenheit, so pretty cold. And let me just move it back towards Boulder and just watch how that updates at the top of the screen, up here. So it's foggy in Boulder, which it is, and it's just below freezing. It's about -1 Celsius, -2. It'll be rounding somewhere around there. It shows you the weather model that we have selected. We're going to talk a lot more about weather models, but just notice that is up there. You can zoom in and out of the map using the usual controls. And as I zoom in and out, the new weather loads. I can also, as I drag the map, you see this, the crosshairs or the reticle in the center of the screen. As you stop dragging, so let me put that over Steamboat Springs, release, and if I click on it, it will reposition the pin to that point. So that's another way of moving the red pin. You can also go to the current location. I can click that button there, and once I give it permission, there we go. I must have given it permission already. It takes a moment to get the data from the browser, and then it will relocate the pin to what it thinks is your current location. This is using the browser geolocation feature, so it's not the same accuracy as you'll get on a mobile device, for example. There is no GPS built into my laptop, but it'll get you pretty close. And given the scale of the weather data, this close is generally good enough. For weather, you don't really want to be zoomed into high zoom levels simply because the weather data isn't of high enough resolution to really matter. You see this model, which is one of the high resolution ones, is a 3-kilometer scale. Let's look at this next button here. So let's go to current location. This one here will zoom you to the bounds of the HRRR model. So it's going to show you the coverage area. So let's click that and watch what happens. So I zoom out. Well, it's zooming me out because it knows the bounds of the model. And then it loads all of the tiles for the entire coverage area of this particular model. Now, if I were to select a different model, let's look, for example, at, here's where you choose a weather model. I'll choose the Arome HD model. That's from Météo France in Europe. And I click that, and we're not seeing anything anymore. It's on the temperature layer still, but we're not looking in the right area. So you can either manually pan across till you find it, or you can just click that button again, and it will take you to the coverage area for that weather model. And from there you can zoom in as you wish. Let's come back to HRRR. So we'll just come back there. And in fact, I'm going to come back to Boulder. There we are. And I'll just back off a little bit from there, just so you get a bit of sense of what's going on. So those are the weather models. I'm going to talk a lot more about the differences between those as we progress through this video. And beneath that, we have what's called the model run. Now, if you're familiar with some of the more sophisticated weather sites that are out there, you might have seen that each forecast, these are computer models, and it's like running a computer program. You have to click start, not click start, but it starts on schedule. It runs, it generates the forecasts, and it does that. Some do it every hour, some do it every 3 hours, some every 6 hours, some every 12 hours. And it varies by model. But what we have here is the ability to select from different runs of the same model. If I click on the time zone control here and put it into UTC, this might look a little bit more familiar. So if you're used to seeing these model run times like 1500 Zulu or 15Z, that's a time in UTC, so it's the time essentially in the UK at the moment in winter time. 3 o'clock in the afternoon UK time, that's when this model run was started. So you might be saying, well, hold on a minute. When I click back to the auto time zone here, it's showing me it ran 3 hours ago. Why don't I have one more recent than that? And that's because A, it takes about an hour or so for the model to run, and then to upload to the service from which we can grab the output. Then we have to grab the output, Then we have to process it all and generate all of these color maps that you're seeing here, and then publish all of that and then update the metadata. So that's why there's always a little bit of a lag between the start of the model runtime and the time at which it becomes available on a service such as PhotoWX. You can choose from different runs. Not all of this is available to free users, but everything is available if you have the Pro subscription. You can check that or upgrade using this button up here at the right. So let's just have a look and compare, for example, the 6 hour ago run with the 3 hour ago run. And let that load. This is at 11 o'clock in the morning. Let me just click between them and you can see that it hasn't really changed that much. Let's look at a different layer though. So I mentioned today was a foggy day. So if I click the visibility layer, there's visibility, and visibility simply gives you a distance. How far can I see? So let's put that in miles. So if it's clear, such as it is here around Trinidad and southern Colorado and around here in, what's that called again? Oh, there's Alamosa, yes, that's, I forget what that valley is. The San Luis Valley, that's what that's called. So relatively clear there. But as you can see around Boulder, it's looking red, so very low visibility indeed. And the point data says 0.2 of a mile, roughly speaking. So let's just drag the pin down here, and you can see 25 miles visibility, so pretty clear. Come back here. And now let's compare this forecast with the one from 6 hours ago and see what changes. And then I'll click between them so you can look for changes. And you can see that it's evolved quite a bit. They were forecasting poor visibility around Colorado Springs and Pueblo earlier, but that's no longer the case. You'll notice that as I change the selected model run, it's still keeping the same selected time of day. So we're looking at the forecast for the same point in time. So you can use these model run differences to compare how a forecast is evolving. So if there is some uncertainty around how things are going to evolve, you'll see that show up when you compare different runs. And if the runs are not really changing very much between them, then that would imply a high degree of confidence in the forecast that the model is producing a stable output. There aren't different conditions coming in each time it runs that are leading it to believe the weather is going to evolve differently. So I've already sort of shown you this, but you can choose between the forecast layers. One thing I should say is that not every model has every layer available. And that's two reasons. One is because either the model doesn't produce that layer or that we haven't yet included it in the service. So as we scale up and scale this thing out, we'll include more over time. But in this case, for example, there are 4 layers here for HRRR which are grayed out. They're not available. Those are for 2 reasons. One is the very low cloud and the fog forecast. There are very few models I've come across so far that include an actual fog forecast. So I can use visibility as a reasonable proxy for fog, and you could compare it with something like low cloud. I just looked over my shoulder. It's snowing hard now here. Just started. So there's the low cloud, and you can see that the low cloud forecast correlates reasonably well with the low visibility area. This is, if I go back to low cloud and look at the definition of low cloud, it's up to about 2,000 meters, so 6,000 feet. So clouds sitting, say, 3,000 to 6,000 feet aren't going to be fog. This is above ground level, but it can correlate with visibility. In wildfire season, visibility can also be limited due to smoke, so you might want to look at the smoke or the near-surface smoke forecasts for that. The other reason I mentioned 2 reasons why these 4 layers were grayed out for HRRR. The other is these 2 layers here, seeing and transparency. Those are particular forecasts for astronomers, and they're generated by only one model that we have today, which is the GEM Astro model. I'll talk about that a bit later, but those are specialist forecasts, and that is the only model that is currently producing them. So let's just finish our tour of the user interface. The next thing I would like to show you is this 3rd button here. When I hover over the tooltip Let's see if I can make that pop up. There we are. It's called Blend Forecasts, and it says displays a blended average of forecasts for the selected time, allows smoother animation, but can introduce artifacts, for example, smeared clouds. So let me just break that down and tell you what's really going on. What I'm going to do first, I'm going to disable it. So there it is off. And the time is at 11:05. I'm in the HRRR model, which runs hourly. So we have an hourly update, and the forecast resolution is hourly. So it has a forecast for each hour that it covers into the future. And if I now, with this disabled, remember everything you've seen so far, it was enabled. I'm just going to scroll forward in time, and you may see I'm scrolling within the hour of 11 o'clock. Nothing is changing. Let me go past 12 o'clock. It changed. Back to 11 o'clock to 12 o'clock. So this is what most weather sites will show you, is that you are seeing these sort of click-through animations, if you will, where it just goes ba-dum, ba-dum, clicks from one hourly forecast to the next. So if I come back to just after 11 o'clock and re-enable that, now watch what happens. And you'll see that we're fading the 11 o'clock out and the 12 o'clock in, etc., as we advance through time. So what that does, it gives you a sort of a better sense of how the weather is evolving. From this, I'm on the visibility layer. We know that the visibility is primarily limited by low cloud and fog and snow and precipitation. So you can sort of sense that this weather's coming in from the north and moving south. I mentioned it says in the tooltip that it can introduce artifacts. Now, if this is an hourly update and you're on the top of the hour, then you're looking at one forecast hour at a time. If I go to 11:30, I'm looking at a blend of two. Well, I will be if I enable it. There we are. And you can sort of see that here, that's one fading in, the other fading out. So one effect of that is that things tend to coalesce around the hour into a sharp image because there's just one forecast. And then they'll get slightly sort of smudged as you go through the across the hour, if that makes sense. Now some layers behave differently with this. For example, I switch back to temperature. And temperature, this is with the blending enabled. Just watch what happens. It evolves very smoothly, and that's because it's more of a sort of continuous phenomenon, if you will. It's not like clouds or fog patches which can move advect, if you will. The temperatures tend to evolve continuously for each point in the grid. So you get a much smoother effect of the evolution here. But watch again what happens if I turn it off, and you'll get that clunk, clunk effect, which isn't so appealing, I don't think. So generally I like that on. If you're having bandwidth issues, things are loading slowly, turning that off will load half the number of tiles, so you can economize on bandwidth by disabling that, if you will. I'm going to put it on. The next button, this one is on. What I'm going to do is turn it off. I'm going to advance through the day a little bit. I'll just come up to, say, here, and I'm going to zoom out so you can really see what's going on here. Okay, and let me enable that, and let's watch what happens. I'm just going to advance through time. You'll see here in the chart, I'm approaching sunset later on today. So just watch what happens. You see that line that is moving across from the top right. It is now intersecting with the pin. There it is. You can just make it out here. That is the day-night Terminator line. There it is, sweeping off to the west. So you can see it quite easily as it moves. And what that is, it shows you the transition from sun up to sundown. And there we are. You can see on the chart we're at the time of sunset, local sunset today, and that is lying on this line. So that is useful for assessing at sunrise or sunset, what the weather is doing around those particular times, and to the north, to the south, etc. You zoom back in a little bit and we'll just look. I think I might come a little bit to the south here, in fact. So I'm going to let's go to Clovis, New Mexico, and I'm just going to drop the pin there. So again, you see whenever you drop the pin at any point on the Terminator, you're sort of at sunset. If I drop it here, you're before sunset. If I drop it there, you're after sunset. But that's how that works. And then let's have a look at, for example, the low cloud layer. So this is quite handy. You can get a sense that the skies are likely to be clear around there at sunset. The sun is setting off in this direction. But let's imagine that you were, say, located somewhere there. That's after sunset. I'll go back just a little bit. And now you can see that the sunset is potentially obstructed by this low cloud. And we can check some different cloud layers as well. Quite a lot of medium cloud, so sunset might be a challenge in that location. Let's look at the high cloud. Not a lot of high cloud. And then we have this total cloud layer, which is just the composite of everything. And finally, multi-cloud. So you can use this Terminator to check particularly what's happening around sunset, sunrise, and with different weather conditions. That's what it's for. I'm going to talk a lot more about these different cloud layers later on. The next one, we'll look at the moon. If you look at the tooltip for this, it says the Lunar Day-Night Terminator. So there's a concept of lunar day, lunar night. Again, I'll just zoom out a little. And you can see that this moon is rising. We're a couple of days after full moon. So we have a waning gibbous moon rising. It'll be rising somewhere in this direction around 9 o'clock. Let's just watch that one, see how that goes. There it goes, and there's the moon is up. So this blue is lunar night. This is lunar day. Lunar day. The moon is up, and again you can see how that interacts with the weather here. Let me move it down here to Hobbs, for example. That's sort of around the time of moonrise, and again, much less in the way of clouds down there than if you were further north. So this might be one of these examples where you say, if I really want to get the moonrise, I'm probably going to head over this way between Roswell, sort of southeastern New Mexico, to try to observe that. I'm not going to necessarily be able to see it up here. Turn that one off. I'll turn the day-night Terminator on. And I think that is most of the controls we've covered now. You can adjust the opacity of the map a little bit, of the weather layer rather, low, medium, high. It's fairly self-explanatory. And the last one I haven't really talked about is this control here. This is a refresh button, and the site will periodically automatically refresh its own data, but you can do it on demand as well. So you can upload the latest and see what's come in. There may be some new forecasts, etc. Finally, if you are looking to translate the site into a different language, we have 7 languages available. So you can put it into German, and all of these weather layer descriptions are translated and localized, so you can read what's going on. We got Spanish, French, Italian, Polish, and Korean at the moment. May add a couple more in the near future, but that's how you can choose that as well. And I will go to English. There we are. So that is a tour of the UI. One more thing I forgot. You can also dismiss these controls and have the map wide open like that. So if you like looking at maps and don't want too much distraction, you can just toggle that on and off like that. There is help down here. We'll be adding more articles in here, but you can click through, read those articles. If you want to see it in full screen, you just click this little button here and it'll open the original in a new tab, just like that. Looking once again at the timeline down the bottom here, we have the sun and the moon altitude chart, as I mentioned. This chart will cover a fixed span of time, and the span of time that it covers reflects the earliest data that we have from the weather forecasts to the very latest. And so only a subset of that time is covered by any one forecast. And the time that is available within the selected forecast and run is shown with the yellow line along the time axis here at the bottom. So if I were to go back to before 9 a.m., you will see that there is nothing displayed on the map. Whereas if I come after 9 a.m., there we have tiles. So that's the beginning of that particular forecast run. And if I, for example, if I choose the earliest HRRR run that's available, watch what happens down here at the bottom as I select that. Here we go, click. And because that run started earlier, the data begins earlier and is available earlier, like that. Now, the other thing that can happen, and it varies model by model and run by run, is that some runs go for longer than others. So for example, if I go to UTC, I happen to know that the HRRR 12 o'clock run, plus the 1800 and the midnight and the 0600 run, they go for 48 hours. And these other runs only go for 18 or 19 hours. And that's a fairly common pattern that you'll find across different models, and which you may find reflected in what's available within PhotoWX. One more small detail I wanted to point out to you as well. You might notice up here that we have cloud total and then an exclamation mark. And on the right I have cloud multi selected. And you think that's not quite the right match, and you'd be correct. And if you click the triangle, it explains why that is. So we get the point data from a wonderful weather service, API service called OpenMeteo, and that's generally fantastic, except that for some of our more specialist layers, there is no multi-cloud point data available. It's sort of a bit meaningless, if you will. So we show the cloud total percentage instead. And you'll see a few other instances of that where maybe they have something that they don't have something that we do offer. Another example is dew point depression, which we'll talk about in a while. Next, I'd like to talk in more detail about clouds. It's obviously a critical thing for many photographers, knowing what the cloud conditions are going to be. And I wanted to just talk you through what we have on offer in relation to that. We've already looked a little bit at the individual cloud layers, so I'm just going to click back to the low cloud layer, and remember that is anything up to about 6,000 feet, 2,000 meters. We have a medium cloud layer, and that is 2 to 7 kilometers, a little bit of overlap in the boundary layer, I suppose, between them, but generally it's that range of altitude above the ground. We have the high cloud layer, and you'll notice all of these are in different colors, and not a ton of high cloud around in these parts today. We have a total cloud, which is a single layer that combines low, medium and high into one, and it shows up in this grayscale from 0 to 100%. And then we have cloud multi, which you've seen. So let me just talk to you about what you're looking at here. There are other sites that will give you individual low, medium and high clouds. The difference in the way this data is presented is to do with the color scheme. And the color scheme that we've chosen allows you to essentially see through the cloud layers to see what is, for example, lying beneath an area of high cloud. And it's to do with the way the colors combine. So we've got the three high, medium, low in the sort of dirty yellow, the magenta and the turquoise. If you combine high and medium together, you get this salmon pink type color, which is something you can see maybe a little bit up there, a little bit over there. if you combine high and low, you get a green. So you can see the green is there. So you've got low cloud here, you've got high cloud there, then you've got a little bit of both layers there. If you combine medium and low, you get the violet purple type color, which is a lot of this area around here. And then finally, if you have clouds at all three levels, it turns to gray. And you can see that there's cloud at all levels in this area. So that allows you to see whether there is low cloud beneath a bank of high or medium cloud, knowing that low clouds are more likely to impact your ability to see the sun or the moon in the sky. So that's what the multi-cloud level forecast does. And remember, for example, let's come down here to Alamosa and just come through to sunrise. What might happen? Well, you'd probably stand a good chance of seeing a sunrise there, because it's quite a distance. It's 60 odd miles before you into the cloud. You can use these tools to get a sense of the scales down here at the right, to get a sense of cloud conditions around sunset, sunrise. The direction of the sun obviously is indicated, and you can get a sense of what types of clouds are present. I'm going to come over to a different model now. We're going to switch to the UK Met Office 2-kilometre model, and I'm just going to click over here to go to view that forecast area. There it is, and there is the multi-cloud forecast for the UK. The UK has a special relationship with cloud, as does much of Northern Europe. There's quite a lot of it. Let me click up here. This is a nice high resolution model, 2 kilometers again. I'll just zoom in a little bit. You can see we're in the middle of the day at this point, 1:56 local time in the Europe-London time zone. Let's go through to sunset and just get a sense of what's happening. So you can see that there's low cloud hanging around the Highlands of Scotland here. This is sort of Skye, the other Western Islands here, and high cloud out well over the Atlantic here. Lower cloud, it's all purple, so that's medium and low cloud hanging around the east coast here and down into the Midlands, and then solid cloud, low, medium, high down in the London and the southeast. There are 2 additional layers available only with the UK Met Office model. I haven't found another model yet that includes them. One is fog, and that's a pretty useful one to have. So this gives you a sense of where the fog is lying. You can see I have the layer blending on, so you can probably get a sense that that is moving offshore. Let's just explore that. There you go. You can see that there. I was actually going the other way. There we are. I'm just scrubbing back and forth. Yeah, it's sort of moving offshore into the south. So that's a fog layer in green, just to distinguish it from everything else. And then in addition, there's a layer here called very low cloud. And very low cloud is actually, in the model itself, it's a discrete layer, and it's basically clouds below 1,000 feet or 305 meters. However, when we were building this, if you show just that layer, you get very ugly, sharp edges where the very low cloud sort of merges into the fog. And so what we've done here is we've put fog and very low cloud together, and that's reflected in the description that we've given to the layer here. So it includes ground level fog and low-lying stratus clouds. So if I just switch between fog and very low cloud, so the fog is a subset of this very low cloud forecast. So very low cloud can be good for atmospheric shots. Probably fog is what you're really looking for, so fog is ideal. Very low cloud is absolutely going to obstruct anything that's sort of low in the sky and off to the horizon. So high impact on how far you can see through the weather with that. But that's our 5, 6 different cloud layers across a couple of different models. Uh, we'd love to have fog with some of the other models as well in very low cloud. That's something we'll have to try to derive our own layers to look at that. Um, so we'll see if we can get that added in the future. So I've zoomed right out. I thought I would give you a tour of the different coverages offered by the various weather models and a few comments on each of them. I'm still on HRRR here, but let's start out with a couple of the global models. You'll see that there's a little icon to the left of the name of each model, and it roughly shows the geographical affiliation of the model. So for example, the two with the globes, ECMWF and GFS, one is the European model, the other is a US model. Both of those offer global coverage. So there's the global coverage of the low cloud layer. And you'll notice that the resolution of the model is listed as well, 25 kilometers. So that's a fairly, it's not a super high resolution model for sure, but it will give you global coverage. So there's ECMWF, the same thing. And you'll see that the broad patterns are similar, but there are interesting differences. So it's always worth comparing models to see what you're getting. Next would be the regional models, and this Météo France Arpège Europe model. It's 11 kilometers, so it's more than double the resolution of these two. And that is a regional model that gives you coverage way up to Greenland, top of Norway, and well down into nearly sub-Saharan Africa. That's Arpège EU. And I'm going to leave Gem Astro till last because it's sort of the exception to all of these things. Then we have the RAP, the Rapid Refresh Forecast. That's a US forecast. It extends quite a way north into Canada, as you can see there. 13 kilometers, so again, a sort of middle resolution model covering a good chunk of North America. And beyond that, we're then into the higher resolution models, which have lower coverage areas, broadly speaking. Let's go to NAM next. You see the coverage came further south, but the resolution increased from 13 kilometers to 5 kilometers. That's the North American mesoscale model. And then at a finer resolution again, we've got HRRR. Same coverage area, better resolution. So those are the three North American models. And then we have the UK Met Office, which covers a swathe of the North Atlantic, into Europe, Scandinavia, and all of northern France, and all of the UK. And then finally the Météo France Arome HD, which is probably the smallest coverage area of all, I think, but extends well down into Spain. Let me just zoom in so you can see that a bit better. And yeah, you can see the borders there. Covers nearly all of England, doesn't quite get up to the Scottish border there. Just about all of Northern Ireland, all of Ireland. So that's a very good one for people in Ireland, UK, Benelux, into eastern parts of Germany. We're a bit short on high-res coverage over here at the moment, but that's something I'd love to add in the future. We need to get a couple more models in the mix to do that, which we will look to do. The good overlap between the UK Met Office and Arome, so you've got two very high resolution models. These are really pushing the sort of the limits of what you're going to find with any model. As 1 kilometer I think is pretty much as good as it's ever going to get. And I think also, you know, it's worth looking in this French model. Sometimes you can see what looks to be, I don't know, it doesn't always match up entirely with what the UK Met Office is predicting. Let's just compare those. It's interesting to spot the differences, and they can be fairly significant, just going back and forth there, like this huge gap here that is in the French model, not in the UK model. And these are forecasts of similar age, they're a few hours old. And then finally, the Gem Astro model, which remember only gives you transparency in seeing, and we'll just scoot over to look at that using that button, and that extends way up into the high Arctic and down into Mexico, a lot of the Caribbean is covered for that model. Okay, let's talk next about temperature and dew point. I'm going to click over to temperature here. We're at around sunset in the UK. Let's imagine now that, let's say we're going to be based up here in Northumberland, where there are nice dark skies and you may wish to do some night photography. We have a moon rising around 9:30, and let's just see what's going to happen. I'll just advance. Temperatures are going to drop a little bit. We are before moonrise. We're all familiar with temperature. That's a commonly understood concept. But dew point, let's look at that. If you're not familiar with dew point, it's basically the temperature at which water vapor will begin to condense out of the air. So if the air temperature is at dew point, then dew will form. And for photographers, night photographers, astronomers, that can run a risk of fogging your lens, so you may get condensation on the lens. So one of the additional forecasts that we have here is what's called the dew point depression. And what that is, it's the difference between the air temperature and the dew point temperature shown on the map here. And what happens is that when that difference is small, i.e. below, say, 3 Celsius or 5 Fahrenheit, that's when you're into a situation where you can get dew formation or condensation and fogging. And as you can see, that's a fairly common situation in England at this time of year. If you scroll forward, you can see how that is evolving over time. Generally, things dry out through the day. I'm going backwards in time here. You can see it dries out. Then the sun goes down, and yeah, we're into a low dew point depression. So that's what that is there for. Next, let's talk about seeing and transparency. Now, these are available with the GEM Astro model. So I select that. We're obviously out of coverage for that at the moment, so I'm going to use my magic button to scroll and show you the coverage area of these astronomy forecasts. So a couple of comments on this. One is it's a pretty low resolution forecast, 35 kilometers. So you're getting sort of general conditions over broad swathes of North America. It shows you 2 variables only, the seeing and the transparency. Let's talk about transparency first. It basically is the determination of how clear the view is upward through the Earth's atmosphere into space. The clearer the skies are for this, the better in terms of the quality of the photos you can acquire. And this is shown on a 0 to 5 scale. It's a unitless scale. 0 is terrible, 5 is great. So you're looking for these darker blue areas, and it includes a number of different inputs. It's noted here: water vapor, dust, pollution, cloud, obviously. But even on a cloudless night, you can have poor transparency due to other factors. Now, this forecast has been around for some 20 odd years. It's produced by the Canadian Meteorological Centre as part of a special forecast of their GEM model. So it takes other inputs from GEM, crunches the numbers, and comes up with these seeing and transparency forecasts. The seeing forecast, that is a reflection of how steady the atmosphere is looking upward through the column of atmosphere. It's affected by things like differences in wind speed or wind shear at different elevations above the ground. And that will tell you how steady a star might appear through a telescope. So if it's doing a lot of shimmering, then that's sort of poor seeing, if you will. So atmospheric turbulence that can distort and blur astronomical observations. Again, it's a 0 to 5 scale. 5 is great, 0 is terrible. And you might notice immediately that the areas that have good seeing, for example up here, may have may have good transparency as well, but may not. This is way up in northern Canada, for example. So those are particularly forecasts for astronomers and night photographers. I should comment that these forecasts, the models I mentioned were first developed many years ago, and that was before we had any sort of smoke forecasts. Now, in North America and Canada, smoke is a huge issue during wildfire season, and even outside the normal wildfire season nowadays. So you probably will also want to consult a smoke forecast. Now, smoke forecasts are relatively recent things. They've only emerged in the last few years, I think fewer than 10. And not all models, far from all models, offer a smoke forecast. One that does, however, and one which I would recommend to you is the HRRR model for North America. I'm going to switch over to that now. It's switched over to visibility by default, simply because it doesn't have seeing or transparency. Let me switch to the smoke forecast. And I'm going to zoom in here down to the southeast of the US, because we're in February, so the fires that you normally see in the west and in Canada are happily not burning at the moment. But we do have some smoke going on down here in Florida, for example. So let's just zoom in there a little bit more and have a look. And what you'll see is that the scale here is it's actually a density measurement that goes up to purple for terrible conditions, and you can see the blue is sort of the very lightest amount of smoke. First thing to look at is what is the definition of the smoke forecast, and this is in fact the total of smoke particles throughout the column of air above each grid point. And so this could be smoke, it could be at near ground level, or it could be way up aloft somewhere above you. And you can look at the near surface smoke to determine which it is. So we can see here, for example, that most of that smoke, this is a similar scale, kilograms per cubic meter of smoke particles. It's not as intense, but it's a good amount of that is near surface smoke. And near surface smoke is measured at about 26 feet above ground level. So that absolutely is affecting the air that you're breathing. So for near ground conditions, look at near surface smoke. For whole atmosphere smoke, look at the smoke forecast over here. If we zoom out a little bit more, what we may find, let's have a look. I'm going to switch back to near surface smoke. And this shows it much more clearly. So you can see there are a number of fires burning here. It looks like the winds are blowing the smoke to the north. But compare the near surface smoke here to the smoke. And you can see that indeed a lot of this smoke, which is a very low level of concentration, is well aloft. It's not near the ground. Just compare that there. So that's smoke and near surface smoke. And sometimes this correlates with the visibility forecast as well. So let's just look at visibility and see what we're getting. We may see, it looks like maybe not in this case, but sometimes you'll see lower visibility correlated with large wildfire activity as well. So the visibility is sort of all cause visibility. So that could be smoke, it could be pollution, it could be mist, fog, low cloud, precipitation, snow, whatever it might be. Sometimes it correlates with smoke and near surface smoke. Other times it correlates more with low cloud and that sort of thing. So finally, let's talk about wind. Wind is an important factor for photographers who are working particularly with tripods, working for landscape, longer exposures, etc. It can be difficult to manage to get the sharpest of shots if the wind is misbehaving. So let's talk about how we can look at some forecasts for that information. I'm going to switch here to wind speed. Well, first of all, I've moved over here to this town called Vernal in Utah. If you're familiar with Colorado, you might know that the Dinosaur National Monument is just in this area here, and a place called Harper's Corner and Echo Park. It's a confluence of a couple of rivers, so there's some good photography around there. I think there are some remote sort of oil field sites with wacky formations that you can photograph in this part of Utah as well. But let's look at the wind speed. Here we go. I'm still in HRRR. And there's the wind speed forecast. This is 11:31 this morning. You can see the scale there. This is from 0 to 86 miles per hour, sustained wind. So wind speed is the average wind velocity measured about 33 feet above the ground. Explanation is down there as always. And you can see that Vernal this morning is in a bit of a nice wind-free pocket, if you will. The higher terrain here and off to the south, you see in orange, so that's getting up to, you know, into the 30-40 mile an hour sustained winds, which would be relatively uncomfortable for photography. Let's just have a look at how this evolves over the coming hours. And you can see the winds are sort of creeping up and creeping in, and then moving off and calming down around sunset. Not always uncommon as the air cools and begins to settle a little bit more, and it's pretty calm after sunset. So that's the wind speed. Let's go back to 11:30ish, and now I'm going to look at wind gusts. So this is the speed of gusts over and above the sustained wind speed, and as you can see, the gusts are quite a bit more. But again, all very calm around Vernal today, per the forecast. Down here is looking sort of into the 60 mile an hour gusts. So that, remember, we had sustained winds of about 40. Just flick back so you can compare that. There we are. But the gusts are more widespread, this is a typical pattern that you'll see. And let's just have a look at how the wind gusts evolve over the course of the afternoon. So you can see that even though the wind is picking up at Vernal, the gusts do a little bit, but not, it doesn't get terrible until late in the afternoon. Then all of a sudden we've got a bit more gustiness coming close to town. And getting worse up here, you can see that's sort of into the browns. That's like 70-ish mile an hour wind gusts down there. So back to 11:30. Now I'm going to show you this one additional layer which we have called wind gust differential. It's simply given as the wind gust forecast minus the wind speed forecast. And so let's just have a look at how it appears. We have a different color map for that and a different scale. It's slightly smaller scale. And broadly, it sort of mirrors the appearance of the wind gust forecast, but it doesn't always quite correlate. And one of the rationales for including this is that if you have a tripod, you can steady your tripod so that it's going to be okay up to a certain sustained wind speed. But if you get significant gusts over and above that, that's when things become particularly tricky, and potentially you're in danger, potentially your equipment's in danger if it's an unexpected gust. So that's what this forecast gives you. Let me just advance along there, and you can see that it sort of highlights more clearly there. It becomes a lot worse. So just at sunset, and you might have experienced this, how the air can become volatile around sunrise and sunset, simply in that transition from there is thermal energy hitting the ground and the air versus there isn't. You saw the Terminator sweep past. There it is, just there. And so there you can see that just after sunset, even in Vernal, the differential of the gusts over the wind speed is quite significantly larger. So that's the intent of the wind gust differential forecast. One more thing to point out, you'll see at the top here, even though I have wind gust differential selected, we don't have a wind gust differential metric from OpenMeteor, so we show the wind speed instead. Gives you the speed and the current direction, and you'll see as you adjust time that the direction will update as to show you from where the winds are blowing. If you've made it this far, thank you for watching. Hope you've enjoyed what you've seen. We'd love to get your feedback on PhotoWX. This is a service that we can expand, and we can add new models, new weather layers, new visualizations. And we have plenty of plans to do so, but we'd love to hear what you would like to see as well. That's what's going to make this particularly well suited for photographers. So please write to us. You can reach us at support@photoephemeris.com, or you can sign up to our forum and post there at forum.photoephemeris.com. And of course, please do visit the site and see what you think at wx.photoephemeris.com. See you next time.